Assalamu alaikum warahmatullahi wabarakatuh. Good morning and welcome to DG Academy. Today our topic is computer hardware. As we all know, we are in Essential Series. Essential Series is one of the series we created for you guys because we found, based on our previous experience, based on hundreds and thousands of surveys, that we should start Essential because this is the gap which we all have from our degree program, certification program, our learning journey, our experiences. We always have gap, and DG Academy believe that we should remove this gap. And how to remove these gaps? By introducing the Essential Series. Essential Series has almost 30 to 35 subtopics and 20 domains, major domains. And our first domain is computer hardware. This is what we are going to start today. We have gone through lots of introductory classes, already recorded, available on our YouTube channel. And this class will be recorded and already be starting and will be uploaded to our YouTube channel. Computer hardware module also has lots of lessons, main lessons, sub-lessons, and we'll go through all, inshallah. Today, our topic is the evolution of computers, the generation of computers, what happened in each generation. Why we are discussing this point? Because we should know our history. As a common phenomena, those who don't know their history, number one, they don't know what happened. They don't know their bad histories. They don't know their mistakes. They don't know what went wrong. That's why they could not achieve bigger milestones. If they know the history, the future will be much faster, much productive. Why? Because they will have learning lessons. What did you learn from your past? And what were the points that gave you high jump? And this is what we are going to discuss in generation. I believe this is the most ignorant part of our studies. Even either you're computer study students or you have done your graduation, you have missed it. I will quickly skip it because these are the total number of lessons and sub-lessons under our Essential Series. And we are discussing about the first part, which is the definitions and the evolution of computer hardware. We'll move to the type of computer as well. Believe me, most of us, we just know the desktop and the laptop. The reason could be many. Maybe because of you did not have a chance to step into server room, data center. Maybe in videos you have seen it, but you did not touch a server, a mainframe, a supercomputer. Why? Because of the accessibility. And this is okay, no problem. But you should know the type of the computers and the generations, and you should know the power of supercomputers. Then if you know it, of course, once you reach to this point, you can have practical experience as well. But based on your learning journey, or how is a laptop and how could be a server, what are the differences? So you can imagine, you can see, okay, these are the components part of my laptop. Then, okay, similar, but much more powerful components might be in the server. DG Academy and DG Info particularly, we believe that you are a student of now and you can be a vendor of tomorrow. And this is what we are aiming, and inshallah, we will take you to a step to the place where you will be confident enough that you will be able to make your own products. We are repeating this vision because this is our vision of our corporate, our mother company, DG Info. So the evolution of computers starts with the first generation of computers, all the way to the fifth generation of computers. Remarkable journey of technological revolution, and this is how it transformed the way we are living right now. Everything is computing. Don't think computing computer has the only meaning which we believe, like laptop and desktop computers, and maybe a mobile phone. No. Computing means anything a digital gadgetry, a digital device which can compute. We will teach you numbering system and how computer, again, computer means electronic device, right? I would like to emphasize on this point. Computer does not have only one meaning, which is a laptop and a desktop and a mobile phone. No. Computer has so many definitions and so many meanings, which there's so many you might haven't seen it yet, but you will see. So the generation of computers can apply on all digital devices. First generation, second generation, third generation, how did it evolve? What are the key elements? What were the key elements and the milestone when the mankind achieved that jump from first to second, second to third, third to fourth and fifth, and now we are living in the latest one. The very dynamic evolution fundamentally change our interaction with technology, paving the way of future where computers play a vital role, integrated role in our daily lives. Yes, this is how it looked like. Maybe you have seen it already in the videos. We are living in the digital world. But just have a feeling of people, those who are sitting in a very large, you can say, football ground or large storage area where we have thousands of cages, or you can say racks, where we have hundreds of vacuum tubes, because this was the time of vacuum tubes. The vacuum tubes, which were actually this was the earlier stage of computing. Again, I would just like to repeat: computing does not mean the way the right now the picture we have laptops and desktop and mobile phone. Computing mean any device which can compute 1 plus 1 2, 2 plus 2 4, and this was the earlier generation of computers which were used to compute the numbers only. Why? Because of this is what the mankind were doing at that time, processing the data. And what were the data? The computings. The numbers and the alphabets came later, but earlier computers were not able to do it. The earlier computers, the first generation, were able to compute only the numbers. The characteristics of these vacuum tubes were very large, very expensive, lots of water because of the heat these generated, the devices generated. And the earlier computer, the first computer which were manufactured at that time, were electronic numerical integrator of computers and universal atomic computers. These were the first generation of computers. And by the picture you can see the area occupied by these computers. Again, when I say computers, please change your perception. Do not bring an image in your mind, okay, laptop, desktop, yeah, mobile phone. No. Anything, any device which can compute, it's a computer. Even your calculator is a computer. I believe that is now clear. This was the starting point of our computing era. And you can imagine, right now you have your smart watches. Just imagine the journey we started from 1940 all the way 2024. That much of time we passed, we achieved our milestone, but this was our starting point. And alhamdulillah, what were the component? What happened after 1956 that changed the whole dilemma of computing? Because you can imagine the tough life of people of that time, that how did they input the data through the punch cards, and output were the printed formats. Maybe most of you guys, you haven't seen the vacuum tubes. I'm sure. I saw myself. Second generation of computers, starting from 1956 to 1963. Transistors, the milestone the scientists achieve because of the transistor that changed the whole world of computing. of that time because of the invention of transistors. And what happened after, you can see, from very large football stadium to one compact room, size reduction and heat reduction and ease and comfort of utilization of the technology. It's smaller in size, faster and more reliable than vacuum tubes. Of course, those who know about the transistors know that how small the transistors are and how big the vacuum tubes were. And this was the time of IBM 7094 series and CDC 1605 series. And this was the time of the programming high-level languages. You can imagine the high-level languages of our time is different. It's like HTML, Visual Studio, and Python. And these are the fifth generation of programming languages. Just imagine how difficult it were at the time of second generation computers, where we use COBOL and Fortran programming languages. I'm sure most of you haven't seen it. And maybe the compilers are available, but not far away. If you go back to 2000, early 2000, what happened? You remember Millennium Bug, this buzzword? Millennium Bug were, I call it biggest fraud in the history, because people made lots of money on the name of Millennium Bug. So COBOL, this was the language of mainframe computers of that time. It started from second generation of computers. And they kept using the COBOL programming language because this was the most popular language for the payroll and computing. Again, the word computing I'm using because this was the time of computing, and computers were used heavily in computing only. And because of this change, once we moved to second generation, the huge reduction in size and accessibility came into the place, and not people in person, but the organizations, the big corporates, they were able to afford the computers from on the government level and the banking sectors and where the money is. But these were the main programming languages of that time. The milestone we achieved and what were the revolutionary point from first to second is the transistors, the invention of transistors. The third generation of computers, starting from 1964 all the way to 1971. Those who are familiar about the electronics, they know this is how the era of computing started, from vacuum tubes to transistors to ICs, which are integrated circuits. And you can see how compact is the size, from a ground field, all the way to a large room. And now we are able to see all of our computing devices from a single eye in one place, more accessibility, reduction in size, reduction in heat and power consumption. And this was the time of IBM System 360 and PDP 800 series. The increase in the speed and the reliability also introduced in the third generation of computers. And again, the revolution of integrated circuits. Those who are from electronic background, they know that how did we actually combine the transistors and we came into the ICs. And even nowadays, the ICs play a major role in microprocessor and microcontrollers devices. These are the chips, microprocessor chips. So this was the revolutionary turn into the generation of computers when the introduction of integrated circuits came into the place. This was a huge revolution in computing, and it was just the multiplication of the transistors in the embedded, or you can say a single chip. So this innovation actually drastically reduced the size and the cost of computers. And this was the starting element of IBM mainframe computers. Now you can see that the mankind, the humanity, they are happy. Why? Because things are in our control. And things are in our accessibility from the purchasing point of view as well. Fourth generation of computers, starting from 1971 all the way 1980. And I'm sure some of you were already born in 1980s. So maybe you haven't seen it at that time, but you might have seen some of the computers of that time in your childhood when you reached to 10 or 15. So this was the era of microprocessors. Again, from vacuum tube to transistors, from transistors to integrated circuits, and from integrated circuits to the microprocessors. Microprocessors are nothing more than the combination of different ICs, combining ICs in a way that computer started learning and making the decision based on the logics. The logic gates introduced at that time also. Logic gates started from the transistor as well, but this time we were heavily using it in computing. So the entire CPU is now on a single chip. And during this time period, the personal computers were introduced in the market. Now, personal computers means everybody can purchase a computer in your home, in your office, and organizations, they were able to purchase computers for their employees. You can see a big shift in fourth generation of computers. Big shift in the way we are moving from manual work to a computing work. See a difference, because I remember at that time from Silicon Valley, the IBM and Microsoft of that time, they were selling their devices all over the world, and they brought these computers to Middle East, to Asian countries, especially in Pakistan and India, and they were selling the personal computers. And those who were really futuristic, they immediately adopted it. Why? Because of they were at the time of nation building. They were like developing countries, and they knew the computers can play a vital role in the development of their nation, development of their countries. Why? Because computer makes life easy, fast, reliable, robust. I don't have any other words to say, but you can see in your life, if you just remove computing from your life, then you are thinking, you will immediately realize like we are living in the Stone Ages. I'm talking about a person. Just apply the same phenomena to the organizations, whether all social media, all broadcast media, all military and civil defenses, anything which is based on the computing devices are heavily impacted of that time. Because I remember the Ministry of Health, starting Ministry of Education, financial sector, they started utilization of fourth generation of computers, because this was not the only personal computers were not the only you can say take beneficiary of this milestone, because in the third generation mainframe computer were introduced, and all the banking sector, they started using it. But you can imagine that if a huge computer is being used in your corporate, let's say in your bank, in your state bank, so very few people, maybe if you have 1,000 employees, maybe 4 or 5 or maybe 10 people, they were trained to use these computers, and also they were the luckiest people they can touch these computers. But since we have the personal computers, it became the necessity of everyone's. And this was the time when actually big social revolution also came. Why? Because of once you have computer in your hand, you can do wonders. And this was the time where even cybersecurity issues started. This was the time of Then we saw the website development, viruses, operating system, Microsoft operating system, IBM mainframe, IBM operating systems, Sun Solaris of that time, Unix operating system came into the play at that time. And once computing and computer devices become in use, it came into the hand of people. Then security issues started. Why? Because of earlier in third generation, the computers were in the hand of very few people, those responsible, liable, trained, and computers were not able to do lots of things. But since the birth of fourth generation, since the birth of microprocessor, everything got changed. There was a drastic change, by the way, in computing world, in the social world, because now people can do everything. People can make viruses, people can hack into the system, people, those who are using computers, but they are not familiar about it, they were compromised. The military and defense agencies, they were able to track what's going on because you have personal computer in your hand and you can do lots of things which can go against these agencies. So viruses came into the play. Also people, the wannabes and also the script kiddies, they were able to, maybe by fun or maybe deliberately, they try to hack into the government and banking computers, mainframe computers, and also the FBI Most Wanted. And if you have seen a film Hackers Most Wanted, you might have seen the hackers were able to reach to NASA servers, NASA storage, and they were able to steal the file, steal the data. So why? How did it possible? Because of the fourth generation of computers. Because this, you can say, unlimited power of computing were in the hand of people. People not govern. People not, you can say, govern is the right word, because there were no policies, there were no laws and regulations of that time that can hold someone responsible. It was the starting of regulations and cybercrime. It was the birth of cybercrime of that time also. Anyways, so most of the computers, the most popular computer of that time were Intel 4004 series, Apple II, and it was the birth of GUIs, the graphical user interface, because now we are entering into the era of computing where people, the normal people, they are using it. So the most important thing of that time, from the commercial point of view, also the speed and also the user interface, because I don't know if you know the history of Microsoft, then you might have seen the Bill Gates. He was more curious about how to make a good user interfaces, how to make interactive, how to make attractive interfaces. Why? Because he knew that if you want to get the attention of the users, that you must make the good interface. This was the time of DOS, black screen, command prompt, text. Nobody liked it, but this generation was for the Windows operating system. The DOS operating system came into the place, and then Windows, the birth of Windows, starting from versions 3, 3.5, 4, and then all the way the Windows version we can see right now in our computers. It played a huge and revolutionary role in computing from personal computers' point of view. And now we are living in the fifth generation of computers. Artificial intelligence, quantum computing, these are the latest technologies of our time. We are living in this fifth generation. And we are focused on AI and machine learning. Those who don't know about the AI, there's a more specific, AI is a separate training, and if you like, we can discuss it further maybe in the next class. But right now, this is not our focus. But fifth generation, you can say, this is generation of our time. AI systems, quantum computers, IBM Q is our latest computers of our time. And you can say the fifth generation of computers is the time of AI. And I'm sure most of you you guys are already familiar about the ChatGPT and the revolutionary steps we have already performed in machine learning and AI of our time. How did it happen, by the way? What were the key elements? Again, as I told you, if we don't know about history, it will be very difficult for us to take the lessons, and it will be difficult for us to minimize the milestone time frame. Now we can see the revolutionary elements of our time, from starting from first to fifth, played from the electronics. Electronics played a vital role in sizing and heat generation, right? Because we saw from vacuum to microprocessors, size and heat. These are the two elements. Size, of course, the computer came from a football stadium all the way to our handrest in our smartwatch. You see the size? And heat, huge amount of water and the cooling system were required. Very expensive at that time. Now we don't even feel the heat in our wrist. So this is the revolution of computers. Now let's discuss about the key elements of the success to move from first to fifth. Again, this is the learning point. These are the learning lessons we learned from our first to fifth. What are the key elements of our success? The evolution of computer technology from the first to fifth. I can say the remarkable journey of the mankind. Beginning from 1940 and all the way, we are living in 2024. From bulky vacuum tube machines that can fill the entire field, all the way to the server room, all the way to the small room, all the way to our restaurant. This transition is because of lots of factors. Number one is technological advancement. Programming paradigms. Miniaturization. What are the miniaturizations? We will discuss it, inshallah. The reliability and efficiency. We saw moving from first to second and second to third. Adoption of a standardization. What are the standards of computing, both from hardware and software? And we will discuss further that what happened once we started to make the standards. It opened up the gate for lots of people, because if we don't make the standards, everybody will make its own. So there's no collaboration. There will be lots of duplication. There will be a waste of resources and efforts. We'll see. Research and development. We all know without R&D, we can't achieve the big milestone. We can't do wonders. Market demand and accessibility, for sure. This is about the profit also. This is about moving the technology from one place to another. Now we are living in a global world. The globalization. These are the key elements of our success from first to fifth generation of computers. Let's deep dive each of them. Technological advancement. Of course, we can see that how we started from vacuum tube and then transistors, and then the integrated circuits, and then how we came to the microprocessors. You can see the sizes, how we move from bigger to very small, the efficiency. And now, by the way, we are living in the AI and quantum-based microprocessors, fifth generation. So electronic played a big role from first to fifth generation of computers. Programming paradigms. From high level, COBOL, Fortran, which came and which we discussed already, second generation of computers. And nowadays, we are talking about script kiddies, programming languages. Scripts are automatically generated by the automated tools. We just move the images from one place to another. We have lots of automating tools which can write our programs automatically. One of the biggest examples are our web development, our Python scripts. We can write the code from scripts, from automated routines, which we can generate the codes. This played a big role in generation to generation. From high level, COBOL, where from, even if I discuss about the low level languages of that time, let's say first generation of computers were the punch card, physical cards we used to punch into the system, and the results were produced. Second generation of computers, we were able to enter the data in the form of the digital circuits, on and off, binary world, 1 or 0. It started from first generation, but actual interaction from programming languages, from assembly language, started from second generation of computers, and then third. So second generation, third generation, we were more focused on. If we talk about system programming, making the operating systems, low level framework and drivers, system drivers, then we use assembly language and C language. But for developers of that time, let's, as I told you, from the mainframe computers, the COBOL and Fortran languages, they were high language. Why? Because of the developers, they were able to make the financial applications. And also the graphical user interface of that time, it came into the place from fourth generation of computers. That improved the interaction and making the computers more user-friendly. This was the second key element of our success. Now, reduction in size and integration of components. This point also, of course, we have already discussed that how did we move from very large football stadium to the large rooms to the machines and then compact computers. These were the key element. If let's say if we did not invent the transistor or the integrated circuits, then there would be no size reduction, and it would be very difficult for the integration of the systems. So you can link it with the first element, which is the innovation of the digital innovation in the electronic circuits, the ICs and the transistors. That helped a lot in reduction of the sizes, and the integration of the component were able to achieve because of the size reduction. This is if we are seeing the computers are compact, easy to access, faster, and reliable. Why? Because the innovation and quality of, you can say, because once we integrate the transistors, we were able to enhance the transistors. The type of transistors came into the place, the logic gates into the place, and the integrated circuits came into the place. So the technology, the invention and the technology enhances the utilization. That produces the reliability and durability of our computing. And again, at the same time, we were able to secure the energy efficiency, because we have seen it. We saw in our first generation, because of the vacuum tubes, they were generating lots of heat, and there we need lots of water to reduce the heat. And that problem solved in the second because of the invention of transistors. And nowadays, we don't even need. And I remember when we were in fourth generation of computers, we still need to run AC or at least fan in the back of our computers. Why? Because of Even the 4th generation computers were generating lots of heats. But now in 5th generation, we don't need AC, we don't need a fan, external fan, in order to maintain the heat. And also energy efficiency means also reduction in utilization of the electrical power. The source, we don't need enough power to run the computers. And nowadays, of course, with the invention of our power batteries, we don't need a live current also to run our laptops and mobile phone. Adoption of standardization, this, I believe, personally speaking, that opened up a gate, and lots of vendors from different parts of the world, they were able to contribute in computing. As we all know, this is the human nature, that if you invent something, and if you don't, and the second scientist, if he does not follow standard, then he will invent the same through a different way. And third engineer or scientist will invent the same thing in another way, and so on. What will happen? The duplication of efforts is a waste of efforts. If someone has already created something, then you don't have to invent the wheel. You don't have to reinvent the wheel. Why? Because of now you have to move forward. So standards, once the IEEE and there were American standards of organization, ISO, International Standards of Organizations, ISO, IEEE, they were focused on electronics standards. These bodies, they created some standards from the hardware point of view. And this was the key element, one of the key elements of the revolution from 1st to 5th generation computers. Why? Because all the vendors, they are following same standard. What happened? A laptop in the USA is the same laptop in Africa, in Europe, in Australia, in Middle East, and in Asian countries. Why? Because of all the vendors, they are following the same standards. Following the same standards, as I told you, we save our time and efforts and the money, research and development, following the utilization and also the user adoption. Those who are familiar about the USB and the storage devices, PCI slots and microprocessor in USA, the same people of the different part of the world, they are familiar to the same. Byproduct of standardization is enhancing and in rapid development. We were able to develop our softwares rapidly. So this was the time of rapid development programming, rapid development of the products with the help of software engineering. Why? Because we were able to follow the standards. We'll discuss about the software, but right now we are focused on hardware. So PCI slots, high-speed interfaces, which were the high-speed interfaces connecting components, let's say the graphic cards, the SSDs, and the network cards with the help of PCI. The USB, Universal Serial Buses, also one of the standards in order to connecting peripherals, let's say the keyboard, mice, printers, these external devices, peripherals were able to connect to the computers with the help of USB. Again, a standard. So this standard allowed other peripheral manufacturer, let's say the manufacturer of keyboard, mice, printers, provided a way to connect to computers, which is the USB. The SATA drives, which are the serial advanced technology attachment, the devices, the drives to store the data. The DDR, the double data rate of the storage. These were the RAM, and we were able to make the DDR3, DDR4, and DDR5 series of RAMs. And the ATX, which is the advanced technology extended, these were for the power connectors, the I/O panel layout, and were the very important. And also from the hardware standard, the most revolutionary part of the computer were the microprocessor. And the standard were many, but most popular were three. The 86 series of architecture, which were actually developed by the Intel. And this was the instruction set architecture. If you remember, 386, 486 of computer, Pentium series of computers, these were the invention of Intel. This was one of the standards of that time, 86 series of architecture, which is the microprocessor. And ARM-based architecture, this were another manufacturer of microprocessor of computers, widely used in mobile devices and embedded devices. So this architecture, which is microprocessor architecture, is widely used in mobile phones, embedded system of industries. It is energy efficient, and that's why we are using in the smartphones, tablets, and IoT devices. These all are ARM-based architecture. 64-bit processing, this was another standard of over all 5 generations of computing. This is actually refers to the microprocessor that can process the data in 6-bit chunks, 64-bit chunks, which allow the more memory addressing and improve performance. And also one of the applications of 64-bit processing is our RAM, which can utilize 4 GB of RAM. This is how it started. I believe if we don't follow the standard of our time, it would be very difficult for us to achieve our milestone of generations. Same thing we followed in software also. The adoption of standards in software, that was a huge revolutions, by the way, of that time, because it was the invention of our websites, our web development, the HTTP, HTML, hypertext transfer protocol, and portable operating system interfaces, SQL, structured query language, also the XML, extendable markup languages, and also lots of IEEE standards, which were actually created for Wi-Fi, for LAN, 802.11 series, if you remember, of our Wi-Fi, our LAN standards. These all were created under the standard of IEEE 802 series. And also programming languages were a standard of that time. C programming, of course, C is not owned by anyone. So that became the standard way of developing, because C is still considered as low-level programming language, above the assembly, but still considered as low-level programming. And I am proud to say that I created a game called Pac-Man, and I'm sure most of you're familiar with the Pac-Man, the face kind of object moves in a puzzle. And advanced version where there were 2 Pac-Man, one is eating and moving in the puzzle, and another enemy which is controlled by the computer is following the one which is controlled by user. And through puzzle you have to defend yourself. Both of you are entered in a puzzle, and you actually have to leave the puzzle in a way that the enemy which is coming back, controlled by the computer, is not able to catch you. So I contributed in module 8 of that time, alhamdulillah. Java programming language, Python of our time, JavaScript, C++. These were the standard, software standard that played a huge revolution. Why? Because of both things are important. Hardware and software, both are important. You cannot say, okay, hardware is important because without hardware, we cannot run our software. Yes, you're right. But without software, you cannot. What is the hardware? It's just a dumb hardware device. It's like chunks of, or you can say a box of hardware doing nothing. Dumb computer, has no brain. If you just remove operating system from a computer, and just for giving you something which, as I told you, every computing device is not laptop servers or thing which we see. There are lots of computing devices which can computers. These are not computers. These are not mobile phones. These are not servers, but we still call computers. One of the examples is calculator. One of the example is our smart, you can say, smart parking, the IoT devices, drones. So somehow they have operating system, but they some are without operating system. But without operating system, I'm just telling you from the high level. From the low level, every hardware has an operating system. We will go deep dive once we learn operating system, but just to tell you about it. The structured query language, if you are from development, if you are a database developer or database administrator, you might know it. The SQL is the core element of our databases. Microsoft SQL Server, SQL as a standard query language, which is used by Oracle, Microsoft, and nowadays open source databases, they all are using SQL programming language, which is used to interact from the actual data and the user interface. Research and development played a huge role because the significant investment in research and development by the government, by the sector, drove the invention. And that's why we were able to discover new technologies. Without R&D, we cannot enhance, we cannot improve, we cannot, let's say, create, develop new versions. We cannot move from vacuum tube to the transistors to the integrated circuits without the research and development. Collaboration is also one of the key elements. Why? Because of collaboration brings people from different mindset. If I'm not able to solve a problem with collaboration, my peer will solve it, because we are from different background, we have from different mentality, we have different capacity, we have, let's say, but we all have common goal. Collaboration from academia, from industry played a vital role in the generations of computers. Market demand and accessibility. For sure, computers become more powerful and affordable. Yes. Demand from business and consumer growing. That's why the manufacturer, they saw the growing market demand. So that's why they started manufacturing plant in Asian countries also. Apple, they started Intel, they started in Taiwan, the biggest foundry of microprocessor. And at that time, I remember late 90s, the Malaysia and other Taiwan, these were the hub to serve the computers, manufacturing computers to cover the Asian, South Asian, and Middle East countries. And the manufacturing plant in Europe and America, they were able to fulfill the demand of computing in this part of the world. So demand, of course, brought new business and made the personal computer available in the hand of everybody, especially in academia and in business. Supply demand, one of the key element of that time. Globalization, of course, every key element has integration, and this is how we move from one milestone to another milestone. Once we adopted the standards and we were able to supply the demand, supply the computers in the hand of everybody in the whole world, then we are actually connected. We became the part of global world, connected world. Remember this word, connected devices, because this is one of the my first lecture in cybersecurity is cybersecurity, which is about connected. Everything which is connected, we have to secure. So globalization, actually, it is all connected devices, the shared knowledge, shared resources, and acceleration and advancement across generations. So these were the main key element of our or you can say key success factors of our journey from first to fifth generation of computers. I will end my lecture today, and I will open the floor for any questions you might ask. Just guys, just raise your hand if you have. Okay, I will just make the allow participant to unmute yourself. You can unmute yourself. If you have any questions, you can unmute by yourself. No problem, I have now allowed it. If you have any question, you can ask. Otherwise, I will just stop recording and I will upload this video on our YouTube channel for you to feedback. This is, as I told you, a hardware beginning. In the next class, inshallah ta'ala, we will go deep dive into the components of computers. Each component, how does it work? How does it integrate with other elements, and how sharing of information, passing the information through connected devices. Very interesting topic of our next class, inshallah. Yes, sure. I will, in the next class, we will, because quantum computing is not a small thing. We can, you can say, dedicate one lecture on quantum computers, inshallah. Maybe next class. Not next class. We will reach to this point where we'll discuss about the quantum computers. Quantum computer is very advanced technique, which I believe this is not the right time to discuss, but we will discuss as it once we reach to this point. I will elaborate more. As I told you, maybe we will dedicate one class on quantum computing because very interesting but very difficult. Yes, any questions, you can unmute yourself, you can ask me, or you can write it here. If no questions, I believe we are done. Please, once we upload the YouTube video, write your open and freely, please. Don't hesitate to write your comments, good comments, bad comments, whatever, on this video. We are going to upload on our YouTube channel, inshallah. Thank you very much for your participation, and see you next video, inshallah. Take care. Assalamu alaikum.